All right, pull up a chair. I want to share a bit of a war story with you today. A truly nasty bug that cost me a ton of time, way too many tokens, and honestly, a little bit of trust in my own system design. If you're out there building agent loops that are supposed to check their own work, listen up because you absolutely need to hear this. Welcome to The Explainer. Today, we're diving into the hard-won lessons of building self-correcting agent loops that fail honestly, and even more importantly, how they can actually recover.
So look at the sheer confidence of this output. No, seriously, look at it. I had just run a multi-agent research loop over a genuinely difficult question, and it came back with this super clean, authoritative verdict. All 25 claims refuted by adversarial verification, research inconclusive. It sounded exactly like what you'd want a rigorous, skeptical agent to say, right? Well, there was just one massive problem. Every single one of those 25 claims was completely true. Several of them even cited real recent papers that I could easily pull up in another tab. Literally nothing had actually been checked.
Here's the kicker. The verifier hadn't actually disagreed with the research at all. It had just crashed. Every single verification call we made had hit a transient API rate limit and returned absolutely nothing. But my loop, it scored that returned nothing as refuted. This is exactly what we call a fail-closed gate that simply cannot tell the difference between refuted by evidence and never adjudicated. It'll lie straight to your face with total unearned confidence and dress that lie up as due diligence. I learned this one the hard way, so you don't have to. Here's our postmortem for today. We'll quickly cover the anatomy of agent loops, dive into the rate limit crash itself, introduce the three-state gate, lay out some hard rules for false negatives, talk about how to resume a crashed run, and finally, how to audit your existing loops.
Okay, part one, the anatomy of agent loops. Let's make sure we're all speaking the same language here.
Regardless of whatever specific framework you're using right now, pretty much every serious agent loop relies on three core roles. First step, the reasoner. This generates your candidate answers. That's your policy. Then you've got one or more verifiers that evaluate those answers, basically acting as the judge or the reward signal. And finally, a refiner that revises everything based on that verifier feedback. Now, sure, all three of these can technically be the exact same model, just wearing different hats, right? But the verify stage, that is your load-bearing component. It's where the loop decides what's actually true enough to keep. And crucially, it is where the invisible failures happen. Think about it. A broken reasoner produces obvious garbage. You'll spot it instantly. But a broken verifier, it produces clean, plausible, and totally wrong verdicts. To put some numbers to this, look at the research from the self-correction bench. They measured a massive 64.5% blind spot rate across 14 different models. What this means is that, while models can totally fix an error if you manually point it out in the prompt, they systematically fail to notice and fix that exact same error in their own prior output. Agents are just structurally terrible at noticing their own mistakes. Generation easily outruns judgment. Actually, fun fact from that research, just appending the word wait to the prompt cut those blind spots by over 89%. So the capability is in there. It just doesn't fire on its own. You absolutely need strong, independent verification.
All right, moving to part two, the rate limit crash. Let's really unpack these invisible failures.
So the gate that I actually shipped in, my failed loop, was a two-state gate. And the rules seemed perfectly reasonable at the time. A claim survives if it gets at least 2 valid votes and fewer than 2 refutations. Makes sense, right? Well, it quietly assumed that votes actually exist. When that API rate limit hit, every single vote came back empty. We had 0 refutations, sure, but we also had 0 valid votes. So the claim didn't survive. Now, refusing to pass an unverified claim was a genuinely good safety instinct. It's classic failing closed, but here is the trap. By safely denying unverified claims, I accidentally dumped all of that silence into the refuted bucket. The summary layer then just laundered that error, turning an infrastructure crash into a confident, research inconclusive. We had completely collapsed a complex 3-state world into just 2 states.
Which brings us to part 3, the 3-state gate. It is time for a new mental model.
We need to update our verifier logic to 3 states immediately so we stop feeding our refiner absolute garbage. First state, confirmed. This means you have a quorum of valid votes. For example, 3 independent web searches successfully verify a specific date. The action, you keep it. Second state, refuted. You've hit your refute threshold. Say the verifier finds a primary source that directly contradicts the reasoner's claim. The action, you drop it because the evidence actually says no. And third, this is the state everyone forgets, abstained. This means you are below your quorum of valid votes because of a crash, a timeout, a null return, or a rate limit. The action here? You don't know yet. You must rerun, escalate, or surface it as pending. Look, think of it exactly like a CI/CD pipeline. If your automated code reviewer subagent crashes, it hasn't approved or denied your code diff. It just crashed. Silence is not a verdict.
Okay, part 4, rules to prevent false negatives. Let's lay down some system design laws. I've got 3 golden rules for you. Rule number 1, classify on valid votes first. Before you ever even look at comparing refutations, count how many votes actually ran and parsed successfully. If it's below your quorum, it's an abstention. You never even reach the refute branch of your logic. Rule 2, errors, timeouts, and nulls are abstentions. Period. They are pending retries. Never treat them as a clean pass, and never, ever treat them as refuted. And rule 3, guard the summary layer. You can never transcribe inconclusive as a finding without mathematically checking if the verifiers actually ran. Enforce this with a tiny report-only reclassifier that just reads the tallies of a run. If your run is dominated by 0-0 abstentions, your summary needs to say verification did not complete, not the claims are false.
Part 5. Resuming crashed agent runs. Listen to me. Whatever you do, do not start over.
The absolute worst thing you can possibly do when a run crashes is throw away the whole thing and start from scratch. You're going to waste massive amounts of time, burn through tokens, and honestly, you'll probably just retrip the exact same rate limit. Your mantra has to be resume, don't rerun. Here is your 3-step recovery plan. Step 1, reclassify. Run that tiny script we just talked about to split your refuted pile into what's genuinely refuted versus what just abstained. Step 2, resume from cache. A good loop harness caches completed stages. You only rerun the abstained verifier calls. You pay for the gap, not the whole pipeline. Step 3, top up the tail manually and gently. Do it sequentially. That shared rate limiter that caused the crash in the first place, it eases up over time. A gentle serial top-up slips right under the radar.
Oh, and a quick piece of advice from the trenches while you're in that recovery phase. Existence check before you refute. When you're manually re-verifying the tail end of a run, it is incredibly tempting to just auto-reject a citation because it looks totally improbable, like, say, a paper with a publication date a few months in the future. Resist that urge. In my busted run, several of those suspicious future-dated citations resolved to entirely real early access papers when I actually inspected them. So check that the thing exists before you swing the gavel.
Finally, part 6, auditing your existing loops. Let's go hunting for correlated failures. I want you to run through this quick audit checklist for the loops you're running right now. Check item 1. Did everything fail at once? That's a correlated abstention, like hitting a shared rate limit. That is not a real mass rejection. Check item 2. If you tighten a rate limit or shrink a batch size, does your failure rate magically drop? If so, you are measuring your infrastructure limits. You're not measuring the correctness of your agent. Check item 3. Take a look at your failed bucket. Does it have 0 per item evidence? No refuting quote? No reason attached? That means those items were never actually adjudicated. Nothing ran.
Let me just reiterate the golden rule of this explainer. An absence of votes is not a vote. A genuine refutation can point at exactly why it's saying no. It'll show you a contradicting source, a failing assertion, a clear counterexample. An abstention can't do any of that because nothing actually happened. If your no can't show its work, it isn't a no. Silence is missing data, not a refutation. Zooming all the way out here, this abstention bug reveals a much broader architectural principle about where we should actually be spending our inference budget. Brute repetition, just letting an agent think longer or sampling more trajectories, it's a weak lever. The research clearly shows that generation easily outruns judgment. The right answer is often already sitting right there in your samples. The agent just can't pick it out. Verification is the true binding constraint of agent scaling. So your design conclusion is this. Spend your inference budget on diverse generation plus stronger, independent external verification. And build that verification so that when it inevitably fails, it honestly says, hey, I didn't check, instead of lying to you and saying the answer is no. The verification step is the absolute weakest link in your entire loop, so it deserves the absolute most defensive design, not the least. So I'll leave you with this question to take back to your own code bases today. Is your agent loop actively confirming reality, or is it just silently agreeing with an infrastructure crash? Ensure your systems fail honestly, guys, because honestly, that's the only kind of failure you can actually recover from. Thanks for joining me on this explainer. See you next time.